Now I'm going to give a very brief introduction to some of the other types of models that are available for other data types. I won't be covering these completely, but I thought it's probably more useful for you to just know what sorts of models are available for what sorts of data and have a rough feel for what they do in the short time I've got available. So some of the models that are available for other data types is something called logistic regression, and that's suitable when you've got a binary outcome. So there's a categorical variable, it's either one thing or another, something either happens or it doesn't. And there's a closely related type of model known as ordinal logistic regression, and that's suitable for ordered categories. And there's a general class of models, and this gets a bit confused because we've already had general linear models, but there's another class that confusingly has a very similar name, which is generalized linear models. And that's suitable for data that have got other types of distributions, so not non-parametric data, which doesn't really have a distribution at all. They do have to have some kind of distribution, but it can be other than a normal distribution. And then the final type of model is survival analysis, where, and I've mentioned this in the first two sessions, where you've got information on some time to an event where the event may or may not happen, and there's models that can be used to analyse that. And there's also broad classes of models that I'll briefly mention that can take account of specific data structures, such as repeated measures data, where you've got things repeated on the same units over maybe the same animal over several time points, and that needs special consideration. And another class of models known as mixed or multi-level models. But we'll first think about logistic regression models for binary out. This is just pointing out that all the things that we did for general linear models can be reproduced and addressed using these models for data with other types of distributions. And we can fit several effects to improve efficiency of the model. We can adjust for confounding factors. You can address two effects in the same analysis. We can test for an interaction, and you can use the model to try and predict things. So all this is possible in the types of model that I'm about to look at.